Here we have the function x squared plus 4 divided by x squared minus 4, and this is what the graph looks like. And so from the graph, we can see that from the left side up to -2, the graph concaves up, and then from -2 to 2, the graph concaves downward, and then from 2 to the right side, the graph concaves up. And so from the graph it looks like -2 and 2, and so to find the -2 and 2 here, and we can find the second derivative and set it equal to 0. That will tell us where these numbers are. And so first, let's take the first derivative, and this is a quotient, and so we have to use the quotient rule. So it's going to be x squared minus 4, and then times the derivative of the top, and then minus x squared minus 4, x squared plus 4, and then times the derivative of the denominator, and then divided by the denominator squared. So this is the quotient rule. The derivative of x squared is 2x, derivative of 4 is 0, so this part here will get 2x. And then the derivative of x squared minus 4, we also get 2x here. So here we'll get 2x, and then here we'll get 2x. And now let's put this 2x right here, put it in front of the parentheses here, so it's easier to multiply. 2x times x squared is 2x to the third. 2x times 4 is minus 8x. Minus 2x times x squared is minus 2x to the third. And then minus 2x times 4 is minus 8x. And then this is the same as x squared minus 4 times x squared minus 4. Here's this square here. So if we do x squared minus 4 times x squared minus 4, then we get x squared minus 8x squared plus 16. The 2x to the third minus 2x to the third will be 0. And then minus 8x will get negative 16x. So this is the first derivative. And now we need to get the second derivative. This is a quotient, so the first derivative is negative 16x dividing by x to the fourth minus 8x squared plus 16. So this is a quotient. And so to get the second derivative, we have to use the quotient rule again. So it's going to be the bottom, so this is the bottom, times the derivative, the top, which is the negative 16x, minus the top times the derivative of the bottom, and then the bottom or the denominator squared. So this is the quotient rule. The derivative of negative 16x is just negative 16. The derivative of x to the fourth is 4x to the third. Derivative of minus 8x squared, it'd be minus a times 2x, because derivative of x squared is 2x. Minus a times 2x is minus 16x. And then derivative of the constant 16 is 0. Minus 16 becomes plus. And now let's multiply the top, everything on the top out. Minus 16 times x to the fourth is minus 16x to the fourth. Minus 16 times minus 8x squared is the 128x squared. Minus 16 times 16 is minus 256. 16x times 4x to the third is 64x to the fourth. And then 16 times 16x times minus 16x is minus 256x squared. This is minus 16x to the fourth plus 64x to the fourth. They are like terms, so minus 16 plus 64 is 48x to the fourth. 128x squared minus 256x squared is minus 128x squared, and then minus 256. And then to get the define the concavity points of inflection, then we need to set the second derivative equal to 0. And so we set this equal to 0, then the top will equal to 0. And then, so let's solve the top. And so now we have 48x squared, 48x to the fourth, minus 120x squared minus 256 equal to 0. And again, the only way this fraction could equal to 0 if the top is equal to 0. And now let's divide everything by 16. 48 dividing by 16 is 3. 128 dividing by 128 dividing by 16 is 8. And then 256 dividing by 16 is 16. And then so it's just divide everything by 16, then this is what we have. And then this is a, it's also in quadratic form. And so to solve this equation, what we can do is let u be x squared. And so now we square u, then we have to square x squared. So u squared is x to the fourth. So in the place of x to the fourth, we put u squared. And in the place of x squared, we put u. And so we end up with 3u squared minus 8u minus 16. And then now we can use the quadratic formula to solve for this equation, to solve this equation right here. So a would be 3, b would be negative 8, c would be negative 16. And so using the quadratic formula, we will get u to be 4, or u to be negative 4/3. So which means that x squared is equal to 4, or x squared is equal to negative 4/3. But this is something squared, so it has to be positive. So x squared cannot be negative 4/3. X squared has to be positive. Therefore, we get x squared is equal to 4. And then take the square root of both sides, we get x to be plus or minus 2. And so we set the second derivative and solve for x. And we got plus or minus 2. And then now let's go back to the functions and evaluate. So this is our original function right here. And then normally we would get the inflection points right here. But the problem is, if we go back to the original function, if we evaluate the function at negative 2 and 2 right here, if we plugged in negative 2, then we get undefined. If we plugged in 2, we also get undefined. And then if we look back at the graph, the reason we get undefined right here, because we have vertical asymptotes at negative 2 and at 2. And so because f of negative 2 is undefined, f of 2 is undefined. We don't have any points of inflection. Even though the concavity it's upward here and then downward here. So it changes at it changes at x equal to negative 2, but no points of inflection since f of negative 2 is undefined, f of 2 is also undefined. And so in summary, that says that the graph is concaves upward from the left up to negative 2 here, graph concaves upward, and then from 2 to the right, graph concaves downward, and then from negative 2 to 2, the graph this is upward, and then from negative 2 to 2, the graph concaves downward. And so that's the concavity